Good evening, everyone. Welcome to this week's presentation of the xLights Gems YouTube series. Tonight we have structural engineering of megatrees and how to build megatrees with John DePlanch. With that, I will turn it over to John. And just to let you know, this is our last xLights Gems presentation for this year. So with that, thank you, John, and take it away.
Thanks, Andy. Um, as he said, I'm here to talk about mega trees. I forgot to do my introduction slide for myself, but John DePlanchi, John D here in the Zoom room for this. Been around in the hobby for quite a while. Talking about mega trees, and just to let you know, I am a professional engineer, structural engineer that deals with mainly bridges, but I've dealt with some buildings and other things in that. So when I'm talking about the mega trees and that, I'm going to try to not keep it too technical, but I'm going to talk a little bit about what goes into it, and then hopefully give you a background why I'm talking about some of these things, why they're important, and hopefully you can avoid some of the mistakes that others have made. I do have a couple of recommended viewing on here. If you're new to megatrees at all, if you're first starting out, or if you even just want a refresher on some of this stuff, there's two videos that I recommend. One is from the very first Existential season that we did. Walter Monkhouse goes into a lot of details about how to make a mega tree, a DIY mega tree. A lot of good tips in there, a lot of good information. Definitely well worth the watch. And then the season two, I did another one about why mega trees fail, kind of building on what he did. This is going to cover a little bit of that, but I didn't want to repeat all that same information. The information that's in here really doesn't go out of date like it does with a lot of the stuff we talk about with xLights and FPP and even controllers that are being done over and over again for different things. So if you have a chance, watch these when the video gets posted. The links will be in there for those who can't write this quick enough because there's a lot of weird characters in there. I don't know if we have the ability to put those in the description on the Zoom or the YouTube channel, but if we can do that, I'll put them in there as well. So, going to talk a little about of the components for a mega tree, and there are a lot of options for these components. So, I'm just going to kind of go over generically what they are. You're going to have the base for your mega tree. Sometimes this is a simple little concrete block, like the portable hole that Walter Monkhouse will talk about. Sometimes it's concrete embedded into the ground. Sometimes people just drive a pipe into the ground. The Megatree kits have legs that kind of extend out and can spread your load out quite a bit. But there's some type of base that will be on the ground that's kind of the like the foundation for your tree. Then you have a pole. That's what extends up into the air. Pretty straightforward. There's a lot of different things that people use for these poles, everything from fence posts to uh, structural tube members on this. My recommendation is always go with the heaviest thing that you can find and afford and be able to lift. Fence posts, a lot of your piping that you're getting at the hardware store that's meant for electrical conduit, that is not designed to be taking compressive loads like you're going to be putting on here or the bending that's going to come from the wind. It just does not seem to hold up as well long term. So it's best not to do that. If you can get real structural steel tubing, round or square, it doesn't really matter. It depends what your base is made out of. In the long run, that's going to be better for you, in my opinion. Most trees also have a topper. You're not just hooking directly to the pole. There's some type of topper that goes on there. Some of these are made yourself. Some of these you can purchase from different people. I always recommend going with a metal topper as opposed to a wood or plastic. Wood and plastic both tend to break. Metal isn't going to break. It may bend a little bit. You might have problems with the welds, but it's much more likely that those are going to hold up more long term than your plastic or your wood. Guy wires, these are an optional thing. If you ask most people, in my opinion, they are not optional. You need these. You want these on there to give you extra support. If your mega tree is a relatively short mega tree, I would say 8 feet or under, maybe you can get away with not having these. But once you get into anything 10 feet or over, definitely put something like this on there. It'll save you in the long run. I will show you many pictures while I'm going through this where guy wires, if they were installed and held up, I don't think the failure would have happened. And then with your guy wires, they can't just lay on the ground. You need something to anchor them down into the ground or to get some weight there to stabilize where they are. Very rarely do see people anchoring these to weights like your base. That is a possibility, but most people trying to drive some type of anchor into the ground. And just anytime you're putting anything into the ground, whether it be for your base or your anchors, please make sure you're calling before you dig. It is a legal requirement. A lot of people will skip that, going, I know what's in my yard. But every year we see posts of people either hitting their sprinkler lines or a couple of their drainage lines, occasionally some of their electrical lines and that. Let me go back here. I jumped ahead a little bit there. Um, so now I'm going to talk about the perfect ideal scenario if you were to design a mega tree and how things would behave. Your mega tree would have perfectly symmetric loads all around, so probably a 360 tree, essentially is that what that would mean. All of your loads would be purely vertical, which means they're going straight down. They're not pulling to one side or the other. Everything is perfectly vertical. Um, your mega tree would be perfectly plumb for the pole. The base would be perfectly level, and there would be no wind or other horizontal loads pulling on the tree. This is very unlikely to happen in the real world. Almost nobody is going to have it perfectly balanced from one side to the other. Your loads are not vertical. Your light strings are pulling a little bit out, especially if you put those bungees on the bottom. It's not pulling with a lot of weight, but it's pulling with a little bit that's pulling it off center. Nobody has a perfectly level yard or is getting out there to perfectly adjust their pole every time. And we're definitely going to get wind. But this is the ideal situation that we would have and where we want to start with talking about some of the design for this. How would this pole fail? Well, I've got it shown on the screen here. And basically, what would happen is the dash line is the center line of where your pole really would be. The weight from everything on the top of it would push down and it would bow the pole out like this. And that's how it would essentially fail. Now that assumes that the top can't move side to side. In a case of a mega tree, it means you have guy wires on there that are holding it perfectly in place, and there's no horizontal loads acting on the column anywhere or anything. So a lot of people look at this going, well, how is that realistic? Well, if you were to take a straw that you get, the old plastic straws, not the metal ones, just push on it from the top. Eventually, if you push it hard enough, you're just going to bow it like this. You'll see that same shape. Maybe you'll crush it somewhere else too, but a lot of times you're going to get this similar type shape. That's what it's going to look like. This is assuming there's nothing holding at the top or bottom. It's free to rotate. This is the shape you would get. But I'm just going to put this out there. Have any of you seen this type of failure with a mega tree? Um, I don't expect you to all answer, but I'm going to say no, you probably haven't seen this. Almost none of, well, I will say none of the mega trees I have seen have had this happen. And basically, that's because usually what happens is the top ends up moving side to side. The guy wires fell, which allow that to happen, or there were no guy wires. It's rare that you have so much load pushing down on it that you just buckle it like this. It could happen in the cases of if you have a very weak pole, like a fence rail, and you were to put a lot of stuff up on the top, hanging a lot of weight of lights on it, putting a really heavy topper on top of that, along with some Toro full of pixels, can definitely happen. But it's very rare that I would think something like this would happen. So I'm going to talk a little bit about the different type of failures here. A little bit of technical stuff here, but it kind of explains it better. With guy wires are these left two images. No guy wires are on the right side. And what you have here is the same image that I showed before, pushing on the top of bottom. It's pinned on the top of bottom, which basically means it's free to rotate any which way it wants to. There's nothing holding it rigid. What we have here is what we call a K factor in engineering terms, and that's just showing what degree of bending this is in very simple terms. When you have that, this is the um, shape of the deflected pull that you would get. Again, this is assuming these are essentially guy wires that are at the top holding it from moving side to side. We're talking still about pure vertical loads coming down on it. If you were to fix the base very, very rigidly, so you were to embed it into concrete into the ground, that ground can't move, that pipe can't bend whatsoever. It changes the shape somewhat because it can't bend here and bow out like this one. It has to go straight and then kink and then it comes around this other way. When that happens, the K factor actually drops a little bit lower. A higher number means it's more likely to fail, so it drops from a 1 down to a 0.85. That means this pole can hold more weight than this pole over here just by fixing the base. These are idealized engineering scenarios. This one is totally fixed at the base, can't move whatsoever. This one is completely free to rotate, can go wherever it wants to at any time, just can't move side to side. It can rotate in any direction. Realistically, our megatrees are going to be somewhere in the middle if we were to have this completely restrained at the top. But it's somewhere between a 0.85 and a 1. You're in that general range, relatively close numbers. When you take away the guy wires at the top, what happens is when you're applying that load at the top, this can move side to side. There's nothing keeping it from going that way. And your deflected shape, if you're pushing too hard on it, starts to turn like this, even if you have it totally fixed at the bottom. If you had the pin like is shown here at the bottom, it becomes unstable, just falls completely over. That's why that scenario isn't shown on here. So you'll see that the number here at the bottom jumps up to a 2.2. That means if you compare this here to this here, you've got a 2.2 factor, which means that much less load can be applied to the pole. There's actually the fact that these are squared when you get into the engineering formulas, which I won't bore you with on there, but it's even more likely it would be up above a 4 because you square this number at the bottom. Square this is still 1. It's like that. If we're comparing the same base conditions here, we have the same here. You're comparing a 2.2 to a 0.85. So this is 2.59 times more likely to get to this shape than it is this way with your K factor. Um, all of this is basically showing you, relatively speaking, how much additional capacity the guy wires give you and why I always say you need guy wires. When not using them is just setting yourself up for failure. And it happens over and over again. You don't really need them in a perfect scenario. If you just have this load here, your pole can probably take quite a bit. As soon as you get something a little bit off, that's where they really help you out too. Like I said, the real scenario here before was idealized, but now we're looking at more realistic, non-symmetric loads, 180-degree tree, even a 270-degree tree. You're pulling on one side a little bit more than the other with your lights. Your lights are not pulling down totally vertical, otherwise it wouldn't look like a tree. It just look like a big column. Nobody wants that. That doesn't look attractive. So you're pulling your lights out, putting a little bending on there. You're slightly off plumb with this. You can see here, not perfectly level on the ground. Most likely your ground is at a slope. You've put it on there. You're like, it's close enough. The bubble's mostly within the little thing that I put on there. It's not perfect, but it's not that bad. But the biggest thing is lots of wind during the show season. It seems like every year, right about the time everybody's sending up their big displays, there's a big storm that comes across the country. I think Florida is the probably most notorious for this because they tend to get a hurricane sometime in October or November when people have put things up, and you'll get a bunch of pictures of things falling down. So this is the cause of most of the failures that I have seen is you get a lot of wind and people people are just not set up for that. You combine that with the fact that not only do you have this here with these, most people put a star or something on the top, as Daryl just pointed out in the chat. We put a big sail on the top. We put a star up there, we put something up there, catches all that wind and makes it bend even more. And again, with the wind that comes during this, the wind itself is bad, but most of the time we get wind, we also get heavy rains with it. The ground gets soft, the anchors pull out, and your guy wires are no longer effective. So, how would the pole fail in this scenario? Well, there's two different ways. The pole, with both the pole and the base, or the connection between the base and the pole, fail. That's fairly common. Or you have bending and breaking of the pole. One of them, they're both bad. They both will fall over. I'll show you a few details with that. When I'm getting into some of this, it's a um, yeah, I'll just never mind that. So here I'm going to talk about the entire tree trips over. I don't think that's actually the case, but let me back up one here. A couple of different bases. This could be for any type of foundation, one that's buried below ground, one that has legs for like the mega tree kits often have, or the large legs that go out 6, 8 feet, or even just the simple little base at the bottom. What happens is if you don't have guy wires holding this in place, you get a wind that comes along, the entire tree starts to tip over. A little more wind, a little weight on the top pushes it even farther, and eventually it goes completely over. Now, I don't have it completely shown on the ground here because I just want to illustrate this potentially could fall on someone. Excuse me. Could fall on someone, could kill somebody if you were out in a public area. Whenever you're looking at a mega tree, figure out where you're putting it and what the risks are for falling on something. People, property, your own house, your own cars, your neighbor's house, falling into the street or anything like that. Like I said before, if you have a relatively small tree, 6, 8 feet tall, the risks of that falling over and doing much damage are lower. You probably don't need a much of worry there. You might not even need the guy wires. When you're starting to get into these ones that are 20 some feet tall, there's a pretty good chance that if it falls, it could do some serious damage depending on which direction it falls into. So you want to make sure that there's no risk. People are going to be far away. The good news is that if it does fall over due to guy wire failure or something like that in high winds, most people are not standing out there looking at your show, so it's probably not going to fall on a person. But there still is a lot of property around, cars, houses, things like that that could be damaged by it. Nobody wants that. Nobody wants the lawsuit associated with it. Nobody wants the headaches associated with that. We're all doing this for fun to get people to enjoy the holiday season, check out our lights, not to have to worry about somebody getting hurt. Bending, this is the second scenario that I'm talking about, where the pole either bends or breaks completely. Same scenario, you get the wind that acts upon it, no matter what type of base you have on here. The base here would be very, very strong relative to the pole. So the pole is weak compared to that. So the base doesn't move at all, holds this in shape. The pole starts to bend a little bit more wind, tips over farther. Eventually, the pole breaks or bends and potentially falls on a car or a house or something along those lines. Both scenarios could happen. They're quite different in that how they're tipping over, but guy wires can definitely help prevent either one of those if they're properly installed. Um, Ideally, if it was a big enough base and a big enough pole, it would never happen like that. But to get a big base and a big pole like that, you're adding both a lot of expense in the materials and difficulty in trying to set something like that up. So I have here just a basic little chart that has this is your base, weak base and a strong pole are possible, a weak pole and a strong pole are possible. When you're very weak on both of them, It's going to be very cheap, but it's also going to be very unsafe. As you move up to strong, it gets safer, but it also gets more costly. If you're talking what is a weak, well, your typical Charlie Brown Christmas tree, very weak pole, bends right over, very weak base, not very big. You could just blow on it, probably tip that over. If you wanted to go into the very, very strong, you've probably seen signs like this or utility poles out like this where you're talking something that's 12, 18 inches in diameter. You got bolts all around that are probably an inch, inch and a half in diameter, snug all around. The foundation is concrete, probably goes down 6 or 8 feet, very heavy. I don't think anybody realistically is going to do this. Definitely not for their home show. Maybe if you have it in a park or somewhere like that, that's a permanent install, you might get something like that. I do recall, I think it was Rob Baldwin was working with somebody, had one where they put it up, it fell over, and then they had to go with something like this just for safety. So you definitely want to keep an eye on what you can do, but nobody's going to be there. Most people are going to be somewhere in the middle here where it's not really cheap, but not really expensive. But it also means it's not really strong. It's somewhere in the middle of where we're going with all of that. And that's understandable, but you want to make sure that you're as safe as you can possibly be with things. So now I'm going to get into some photos because I think that's what most people can really identify with and see what's on there. I pick a lot of these up just from posts on the various different groups that we're in. So I did not have the chance to reach out to everybody, but these are all on Facebook, so you can find them there. It's not like I'm stealing them from personal pages of people I know. It's what's been posted in the various groups on here. So the first thing I'm going to talk about is tipping of the pole or the base connection. You can see here where the connection to whatever type of base this was, to me, it looks like it was some type of plywood. It just separated right out of where it was. The pole here, I put it's a strong pole because the pole doesn't look like it is bent at all. The base or the connection was just weak, broke right off of there, tipped right over. Connections are very important when you're designing a mega tree. You want to make sure that you have something that's going to be sustainable. It's embedded in there. It can take some of the load, most of the load, in fact. You definitely want it holding up for when you're erecting the pole before your guy wires are installed on there. But even if your guy wires fail, hopefully that will be able to maintain it at least for a short duration. Um, with all of these ones here that I am showing, if you do anything, put guy wires on here. Sometimes you'll see them on here and they have failed. And if they didn't fail, the tree most likely would have stood up. But I'm just trying to go through a lot of the different scenarios and show what's going on with them. So always watch your connections. Make sure you've got something suitable in there. I don't expect anybody to design it. You just need to kind of look at it and say, where is my weak point on here? If this is your weak point, there's a good possibility you get a strong wind, it's going to break apart like that. Here's another scenario where very strong pole, in my opinion, because neither of these poles look like they have bent all that much. And if they did, it was probably from hitting the ground, not from the wind. But the bases just tipped right over. They weren't heavy enough to support what was going on here, probably weren't staked into the ground. I don't see any evidence of guy wires on here that were really holding up anything all that much. Um, Again, this is one where he's kind of close to the road, kind of looks to like the neighbor's property is not too far over there. There's a fence here. If it falls in a different direction, you got some pretty major property damage there that you probably don't want to deal with. At the very least, you're only hitting, in this case, these your own props, but nobody wants to replace all that stuff if you don't have to. And as we mentioned before, the star here laying on the ground looks like it was probably connected in here. Big sail pulling this whole thing over, catching all of the wind. Your base is very often the weak point in there. To make up for a weak base, you either need to put more concrete in here, make it bigger, make it wider. That'll help it from tipping over. Or as I have mentioned and will keep mentioning, guy wires always help these type of things out. You when you're going against Mother Nature, it's tough to win the battle all the time. We're not always going to win, but you want to do the best job that you can. Again, another scenario, this may even be from the same house, tipped over, Same general thing. I put on here, this is a lucky window. It's new, not too far from tipping over, going through that. Nobody wants to go through a thing where that shatters the window. Now you've got that coming through. It was probably a windy day, most likely a rainy day. You don't want to be dealing with that in the middle of your light show, having not only that fall over, but now you've got damage to your house too. Um, so just be aware when you're setting these things up. If it were to come down, what's it going to hit? Are you okay with it hitting whatever it's going to hit? If it's hitting your property, not nearly as bad as hitting a neighbor's property, but you don't want to hit either of them, in my opinion. Here's another one. This is one with the very large legs that are sticking out there. Again, I'm going to call this a very strong pole. Doesn't look like it is bent whatsoever, but it's a weak base. The base hasn't bent at all, but there was nothing to stop it from tipping over with the very high wind that was on here. Now, these pictures were posted together. This, I believe, was a hurricane that came through the area, took down this real tree in addition to the mega tree. If Mother Nature and the trees there aren't going to survive, is this going to survive? Maybe if we design it well enough, but there's a good chance that it's not going to happen. We're dealing sometimes with very, very strong winds, as I said. A lot of them seem to happen about the time our shows go up. This one, it doesn't look like it took all that much damage to the tree, so they were fortunate, but you still probably have to take most of this apart, disassemble everything, get it back put up. You're talking a couple of days worth of work there. Not what anybody wants to deal with. Here you can also see where there were guy wires here. They're slacked on this side. This one, I can't tell quite what it's connected to if it caught something. But the fact that nothing here seems to have broken would say to me that the guy wires really didn't do their job, probably pulled out or broke somewhere that I can't see on here. So had they had better guy wires or a heavier anchor system, stronger anchor system, it may have allowed the tree to survive. Going into again another one that we have very strong pull relative to the base. Again, looks like the base just pulled out from what it was anchored into. I can't tell if this is a wooden pallet or something along those lines, but this did not hold up with the connection well. No guy wires to prevent that from falling over. I labeled this one over here, but you can see there was another over here. Had it fallen backwards, might have hit part of the house, tough to tell, but definitely looks like it could have hit any one of these vehicles had it fallen in a different direction. Again, be very careful where you're putting these things. It's one thing to do damage to your house or cars, but you don't want to do it to a neighbor's. Please watch where you're putting them. Make sure it's designed properly. Just to point out another one, because these large bases are becoming more and more common, and you're seeing some of the kits that are available emphasizing, hey, we got these really big bases. This can go up to 20 feet tall, and you're not going to have any problems with it. Well, you can see from this that's not always the case. It can happen. It does happen. Doesn't look like it took too much damage, but you're not just going to be able to go out here, pull on it, stand it right back up easily. You want to make sure you have something to prevent that when you're doing it. So all of those that I just showed were tipping, where the pole or the base connected, but you didn't get too much bending of the pole. Those all had relatively strong poles compared to the base. Now I'm going to get into a few where the pole wasn't so strong. The base was good, at least compared to the pole, but doesn't always happen that way. You can see here very big topper on top of this one, takes a lot of wind load, but this pole, just looking at it, looks very, very thin, not properly sized for what it's trying to do. It looks like it's anchored into the ground here. That held up well, maybe a little bending on here, but the pole was weak compared to it. It just could not stand up to the loads on here. You can see over here, guy wire that's going up a little ways. I don't know how many they had on here, but clearly not enough to support that. One thing you also have to remember is guy wires will only protect what is below the guy wire, nothing above it. Doesn't mean you have to go all the way to the very top of the tree, but if you're connecting at this location here coming down, in this case, something must have failed because this bent below that. But if you're connecting at this location, anything above it can still tip, blow around, move any way it wants to up in the air. You can get failure above that. I would always put your guy wires up as high as practical. That doesn't mean at the very top. That means get them up as close to the top and make your connections where you can. Definitely no farther down than a third of the way would be my recommendation. But if you can get them up three-quarters of the way, seven eighths of the way, you're much better, much higher up. Another one here with a nice base. I'm not sure exactly what's in here, but they've got some timber here, probably some weights in there. But the pole was just not strong enough to prevent bending, tipping right over. You see one guy wire here that's keeping it most likely from tipping all the way over. It's tough to tell with the angle on here, but it wasn't enough to keep it from bending at least a little bit. Again, this one here, I call this a weak pole because you can definitely see the bending in the pole itself. Strong base, I'm not quite sure. This has tipped a little bit, so this looks like it may not be in concrete, just driven into the ground. Maybe that bent a little bit, started this getting off plumb. A little bit of wind exacerbates that situation, tips a little bit more. When you're putting a base in, you want to make sure that your ground isn't going to be moving around like that, that you got enough concrete or that to hold it in place. Something that was pretty popular back several years ago, I think people are getting away from it, was using threaded pipe to go into here and then going into a matching threaded connection going into a portable base. Threaded pipe really is not designed for bending whatsoever. The threads damage it. You start getting rust in there because usually it's not covered with that. They tried to prevent some of this, but not all of it. You can see where it corroded, and it just broke right along there from the looks of things. This base ended up being very strong. He's got anchors down into rebar. Looks like probably eight or nine of them around there. The base was no problem, but the pole just did not hold up. Doesn't look like it bent at all, but that connection at the base just couldn't stand up to the loads because that's not what this pipe is designed for. You'd never see a threaded connection being counted for any bending in any real structural engineering purpose. It's not a good idea. Avoid it if at all possible. If you can't avoid this, if this is all you have, make sure you have guy wires on there that are very, very strongly connected that aren't gonna pop out in any way. This looks like this was one of the guy wires hidden under my arrow there. Probably came out, led to the entire failure on this. So I've talked a lot about guy wires. I really think they are important for this. If you could not tell, they restrict the movement at the top of your tree. They take the load off the top because instead of it trying to bend the pole, it goes through the guy wire and it makes your tree less likely to fail. Going to talk about a little bit of the loads that would go into there. Walter Monkhouse goes into a little bit of calculating the load, so I'm not going to go into that here. But it's all based on angles. So let's say you have a 10-foot tall mega tree, your guy wires are 5 feet out. Ideally, you want them as close to horizontal as you can get. Realistically, nobody's going to put them out 30 or 40 feet because you can't get that far. So here I just assumed it was half the height for something. That results in a guy wire length, if I were going right to the top, of 11.18 feet. For those of you that remember your geometry or trigonometry, that would result in an angle of 26.56 degrees. If I put a load at the top here, it uses these same proportions to figure out what the load is. So if I have 100 pounds blowing on my topper here from the wind, it means coming this way. As you can see, 5 feet to 10 feet, I've got 100 pounds coming this way. When the force is acting on the guy wire in this, it means there's 200 pounds acting on the pole and 223 pounds acting on this guy wire. And also trying to pull this anchor out of the ground is 223 pounds. So you can see how fast a little bit of load up here influences way down here. The closer you get to horizontal, the closer this is going to be to the exact 100 pounds here. No additional load in the pole. As this angle gets smaller and smaller, this load here on your anchor and your guy wires will get greater and greater, and as will this. Something to pay attention to with this, and I know a couple of the guys in the Zoom room when they've been talking to people, when you're tensioning up your guy wires, you don't want to over tension your guy wires and put a lot of force on them because any force you put through this guy wire is going into your pole as well and could potentially buckle your pole, like I showed in one of the first slides with that little arch shape. The good news is if you have the guy wires at the top, these poles are relatively stable. You're probably not going to do that, but you don't want to be putting hundreds of pounds of force through your pole for no reason. Want your guy wires to be snug. You don't want them vibrating around, moving too much. You want them to have a little bit of tension in there. 10 or 20 pounds of tension is plenty in there, but nobody knows how much that is. If you're using wire and you pluck it, it should make a little bit of a musical type noise if it's thin enough. If you're having the straps, they should be sturdy. They'll also just vibrate. But what will happen is the vibration should dissipate very, very quickly. If it's shaking for a minute, you don't have it tight enough. Put a little bit more pressure on it. Um, but don't over tighten these things. You want them snug. Just like anything you see when you're assembling anything, don't over tighten. Over tightening is always bad, and that's the reason here is you're putting too much there. Also, as you're pulling down farther with this, if you over tighten, you're starting to pull your anchor out of the ground if you're over tightening that. And now your anchor can't hold up your tree when the wind blows because you've already pre-tensioned that. There's several different things that you can use for guy wires. Aircraft cable, steel cable is probably the most common, and in my opinion, looks the best just because you can get it relatively thin that holds quite a bit of weight. 16th inch diameter cable will break at about 480 pounds. That's the advertised breaking strength. The working load limit is always less than that. That's what they call the safe capacity for it. We're not holding anything up where we're holding people, so you probably don't need to be quite that low. But this is where the factors of safety come in and they know what they're talking about with these. So if you're worried that you're going to have a lot of load, look at this working load, make sure that you're in a reasonable proximity to that. Definitely never above your braking strength over here because that's when the thing will actually break. These tables, you might not have this available for all these different diameters at a store, but when you go to buy cable, even if you just buy rope or some of the straps, they'll tell you what the working load is right on there. Any piece of um, any decent thing anyway will tell you what it's rated for based on that because people are buying this to strap things down, connect things. You want to know how much load it'll hold. Again, bigger is better, but bigger means that you can't make a connection quite as easy. Usually something in the eighth inch diameter is going to be plenty for our purposes on these. But if you're getting into something that's in the 20, 25-foot range megatree, you might need to go a little bit bigger and make sure it's working. But something people forget about is this cable. That is perfect condition cable, brand new, out of the box, no corrosion. You can see on here the corrosion narrows this down pretty quickly, rust all over on here. Over here, oh, I've used this 3 years in a row, and when I put it away, it kinks a little bit. Every little kink like this takes away capacity from the wire. The rust reduces the area, it doesn't work quite as well. Always check your cables before you put them back up. The cables are not that expensive if you have to replace them. Make sure that you're using good cable that's in good condition. Take a look at it. Make sure you want to use that you trust it holding up something. If you're careful with it and you put it away nicely, you make sure it's dry, it's going to last you a lot longer. But most of us are taking these shows down February or March, maybe even January. Things are wet. You want it just out of your yard. You throw it in a bucket, you leave it there. When you pull it back out in October or November, there's still some water and there's some moisture. I get it. It happens. But if it gets too bad, make sure you replace it. Don't risk your tree falling over because you just didn't want to take the time to do it. Same with the straps. Straps are good too. They have quite a bit of capacity. Check them, make sure they haven't snagged, make sure nothing started chewing on them. The rodents love to chew on these things for some reason. You put it away, you snag it a little bit, it catches on something. Make sure it's in good shape before you use it. It doesn't take that long to look at it to make sure everything's good. Check it either before you put it away for the winter or when you're setting it up, preferably both, but definitely one of the two. The anchors, they're as important, if not more important, than the guy wires. As I mentioned before, they're often the source of failure because the wind and the rain usually come together, especially when we're talking about the very high winds. It's at a front comes through the area. You get a bunch of wind, you get a bunch of rain, softens up the soil, things pull out much easier. If you're using anything that's embedded into the ground, be careful of that. I got a couple of pictures here with failures. This is just the anchor that was in on this one. Simple little thing at the bottom. You can see where that pulled out. Did not hold very much at all. I don't know how windy or rainy it was with this, but it just shows you how easy these things can pull out. They'll take the soil right with it, especially if they're not deep enough. Another one here. This is just a blow up of the same thing, so you can see what you're seeing at. Pulls a nice cup shaped failure right out of the soil. Doesn't have too much that it's embedded into there. Does not look like it was all that deep. Deeper is always better with the anchors. The more spirals they have around here, typically better as well. This just didn't hold up all that well. I don't think this was on a guy wire. I think this was just on their frame or something along those lines. But still, pulled out very, very easily. Just want to show you how what that looks like when it does happen. Another case here, these are commonly used for tying down your dog. They are not designed to hold any significant weight, especially pulling straight up on this. It's designed for side to side action. It can pull the soil right out in here. Something you have to watch with any of these anchors, just like with screwing a screw into wood or plastic and that, you don't over tighten it. Once you over tighten it a bit too much, it breaks the soil boundary that comes around here. Now it's just spinning around. The soil against soil, when it breaks like that, is not providing you any capacity, can pull out pretty easy. Make sure you're not tightening these too much. Make sure you know how it's supposed to be installed and you're doing it properly. Also, if you're using ones that are designed to be removable, don't put them in the same place 2 years in a row. Mix that up a little bit. Your soil breaks when these things go in, breaks apart. They loses capacity if you're putting them in the same location year after year. This year is another pole that came over. Now, on this one here, there were some problems with the weld at the bottom here that they attributed to the failure. Personally, I think looking at it, it might have been that combined with this guy wire stake pulling right out. You can see where it is here. It's a smooth stake. It looks like it was driven fairly deep, but there's not much holding this into the ground, especially if it's wet. If you have a failure of the connection point here at the bottom, that kicks out a little bit. But if your top was totally rigid, there would be nothing making it go side to side. It would stay in place. This might be a little bit offset, and a lot of the force is going to your guy wires, which would keep it where it needs to be, even though it was leaning a little bit. But you can see here, this just pulled out. You want to make sure those anchors are going to be able to take the weight of your tree if it tips. Um, One of the better places I have found for any type of anchors, both for a hobby or professionally, is American Earth Anchors. They have some very good charts. They have a lot of different soil types on here, a lot of different options. Some of them can get quite expensive, but I'm just letting you know what's out there. Obviously, the longer they are, the deeper they go. And the deeper they go, the more capacity that they have on here. They also break it down by the different type of soil conditions that you might have. You probably don't know what you have, but you can get a rough idea. If you don't know, go to the bottom of the list because that's the most conservative to use. That's safer for anything. But if you have something that's very hard, like asphalt, then you're going to be up here at the top. But if you have just like your loose sands or even uncompacted fill, you just put a bunch of dirt in place, it drops fairly significantly. You can see here, if you remember when we were talking about the capacity on the guy wires themselves. That was up. Even the thinnest wire had a breaking point that was over this 400 pounds. A 9-inch anchor is going to pull out before your wire breaks. Whether or not that's the way you want to go, that's up to you. Personally, I would size my anchor so that my wire breaks before my anchor so that I don't have this pulling out of the ground when I least expect it. So I would go as big as you can and as deep as you can for what you can afford and what your soil conditions may be. In addition to these screw type ones, they do have other ones that have, they call them bullet or arrow heads. You drive them down into the ground, these kind of tip out a little bit, prevent things from popping out. These go down much deeper into the soil than the other ones, and they have more capacity because of that. However, these are not as easy to remove. They're more of a permanent installation type thing, which a lot of people aren't going to be able to use, but just letting you know that they are out there. One thing that's important is you can't find the load capacity. You're just guessing on how much it can hold. Those dog tie downs are going to tell you it's good for 100 pounds or it's going to hold a 75-pound dog from running away. That's not really a load capacity. You're looking for something like the charts that I just showed here that tell you based on different soil conditions what it is able to hold. If somebody is trying to sell you something and saying this is awesome and it's going to hold everything you need to at that, ask them what the load is on it. If they can't tell you, don't buy it from them. Find somewhere else where you can get it from. Home Depot, Lowe's, any of your big box stores, it'll say right on the package what it should be for, or check their websites. You just got to watch if you're going online and just searching Anchor and somebody tells you, yeah, this will work fine. Second guess that, take a look at it. A couple of miscellaneous things. Um, a lot of these newer poles that are going up higher use a strap to pull up to the top. Very easy for these straps to get worn out over time, break apart here. Again, always check your straps, cables, no matter where they are. This has a very large star at the top of it, very heavy. My understanding is that either this strap broke or there was a problem with the topper that was holding on the star. I don't know if you ever figured out what the problem was, but two different points that you want to make sure are very, very strong so that you don't have something like this happen to it. Takes down your whole tree because of being somewhat under designed. As I mentioned before, toppers, you can make them out of anything you want to. This one was made out of wood, but you can see right here where the line is, the wood cracked, broke apart. He had to reinforce it with the metal on here to get it back up, get the show going. If you can get metal, use the metal. I wouldn't recommend this threaded type. I would put it on a real pole that doesn't have a threaded end. But if you're going to make this work, you do some type of reinforcement around here in both directions. The wood is going to typically break along the grain, so you want your reinforcement in that direction. Look to see where that grain is when you're putting these on here so that you're not putting all your weight on one side and the other, forcing it to bend in that direction and break there. Here's another one where the poles bent, come down, and all that. This is not really to show you that anything in particular, except for we get some very strong winds. I believe this is Bill Porter's house, who lives down in the panhandle of Florida, and he's very good at documenting things. I'm pretty sure this is from him. If not, I apologize. But his wind speed at when the time he took it was just about 16 miles per hour, but his peak was almost 70. This is some of the other damage that it did in the area. These are design structures that are designed by engineers for all sorts of different winds. They don't even hold up all of the time. So if your mega tree comes down, understand that sometimes it does happen. You guys aren't engineers typically. You're not designing this. You're just trying to rig it together. You just want to make sure that you have something that's as good as you can possibly get, that it's going to take something that's in the 60, 70 mile per hour to take down. You don't want it coming down at just a 10, 15, 20 mile per hour winds. So keep that in mind when you're doing it. Don't kick yourselves with this. I appreciate when people put their failures online so everybody can learn from them and say, hey, I need to go a little bit deeper with my anchors. I need more guy wires. This top fence rail isn't really working. Everybody learns from those type of things. There's a couple other videos here I want to share that people did. Let me see if this will go to them easily. So a couple other things you have to watch, and I will just go into here. This is somebody that they were taking down their video. This isn't in the middle of a windstorm or anything like that, but as he says here, he didn't want to wait for his wife to hold the pole. He's like, I'll just let some guy wires out so it doesn't take his wife as long to wait. And you can see the tipping that happened as soon as he takes some of those guy wires out and going on the other way. Fortunately, it was short enough. They were able to catch it, not do too much damage. The bigger, heavier that is, that could have been could have injured him very easily trying to catch something like that or done some damage as it comes down. So pay attention both during assembly and takedown. It's not just the wind. Your guy wires are doing something all the time if they're hooked up. When you're taking them down, make sure it's symmetric. Probably have somebody holding the pole if you can to keep it plumb when you're doing things like that. Gonna go to another one here. This one, as you can read here, they had some winds. Said it broke the center tree. I think he means just the fur up there. He started cranking it down, but he lost control of the wind. And you can see what happens on this when that happens. Whole thing comes down pretty darn quick when he's doing that. Had he been under here, I'm sure he would have been injured quite quick. All of these winches that are on these trees, they're a great idea. They work really, really well most of the time, but you got to make sure you know what you're doing with it, how to crank it up, how to crank it down, how to stop it if it does start to get to these really runaway conditions. Some of them have automatic stops, some of them don't have anything on there. Be really careful when you're doing this. Nobody wants to see anything like this. Nobody wants to get hurt by anything like that. This one, unfortunately, I can't make this any bigger, but this is some nice video somebody got of a trampoline blowing around in the windstorm. And you can see over on this side, the mega tree will come down very shortly after. I don't know. Yeah, full screen makes it a little bit bigger, but not much bigger. Let me replay that there. Um, as I said, there's sometimes you're just not going to prevent your mega tree from failing. I don't know if that trampoline took out the guy wires and that's when it fell. There's nothing you're going to be able to do to prevent that. We can't guarantee it's never going to come down. That's why I say position it where if it's going to come down, it's doing no damage to other people or property or anything like that. Um, just talk a little bit about tree kits. There are definitely pros and cons for all the different systems that are out there. I see more and more vendors coming up with things all the time that they're marketing on here. It's great to have options for them. I think it's great. A lot of people don't know how to design anything like this or how to construct anything like this on their own, and this gives lots of options. Just a few things to watch out for with these. Be careful of what I'll call marketing gimmicks. And this goes for even buying your pixels and things like that. If it sounds too good to be true, it probably is. If it's very, very cheap and you think you're getting something that's, again, too good to be true, you might want to look into that a little bit closer. Make sure you're getting what you want. Don't go for something because they say it's bigger, stronger, heavier duty, been tested for this, been designed to do this, but don't give you any details on what it exactly is. I can tell you that those are 10% brighter than other pixels, but if I don't tell you what the other pixels are, well, Are you sure they're 10% brighter? Or am I just telling you that to see if you'll believe me or not? I can make a tree that's stronger than somebody else's tree, but if you don't know how strong their tree is, that's useless. There's a lot of little vague things that some of these people are putting into their descriptions that, as an engineer, bother me because they're not really saying anything that means anything realistically. They're just putting it in there for marketing terms. Um, Also, you want to look at it and you want to see if people have limits on things. Do they give a maximum height, or do they just say, well, here's a base and you can put a pole in it, but don't tell you how much that's really going to go for? Do they have how much weight it can hold on the topper, or a maximum wind speed before they think it's going to topple over? As I showed, it might topple over with the pole bending, it might topple over from tipping from the top. But if you've got a kit that has all of this stuff and they're not giving you any indication of what that would be, how do you know what you can really do on it? Also, you can ask them or see if they say whether it requires the guy wires and anchors. Um, Most of these trees will hold up much, much better with the guy wires and anchors. But if they're saying you don't need it, well, do you not need it because you can't put a topper on it? Do you not need it because you can only go 8 feet tall? You want to check these things before you purchase anything, especially because some of these are costing thousands of dollars. It's not just a simple little thing. So before you spend that kind of money, make sure you know what it is. Also, see if there's any warranty that's included on it and limits on the warranty. I have been asked by a couple of different vendors to design Megatree systems for them, and I have refused because I would have so many limits on there that no one would be able to assemble this in their front yard. I'm an engineer. If something happens and someone were to get damaged, they would sue me. I don't want that liability, so that's why I haven't designed these. But I would have to ensure that the thing is perfectly level, that it's up to this high, that the guy wires are installed this far. There'd be so many limitations on there. I probably wouldn't have to pay, but I'd have to prove that somebody didn't follow all these things exactly, and that's just not worth it. And then the final thing is check to see what's included. Some of these kits say that they are including a lot of things, but they don't clearly state all the time what is and is included. Sometimes they'll give you the base and the legs, but not the pole. Sometimes the toppers are sold separately. Sometimes they include lights, sometimes they don't. Check and make sure when you're comparing them, especially that you're comparing the same type of things so that you're not getting something that comes in a package and all of a sudden, hey, I still need to buy um $1,000 worth of lights to be able to light this thing up. I thought it was going to be everything that I needed. So just pay attention with those. Not saying all of them are bad. Some of them are great out there. I'm not mentioning any of them by name and that. That you'll have to look at if you want to have a private conversation with me. I'll do that on what I think is good and bad on them, but I'm not going to put that in anything like this. That's really all I have about there. It kept it under the hour with that. If anybody has any questions, I will be happy to answer them. So see when they're, would you suggest screwing them into the ground vertically or at an angle against the guy wire direction? It depends on the type of anchor. If you're getting the ones that are the screw type anchor, most of them are designed to go in vertically. They have a plate, a round plate, usually at the top that prevents it from going too far into the ground, but that's intended to sit level against the ground when it's all the way in. If you try doing it at an angle, it doesn't work quite right. The ones that were those bullet type ones that I was talking about, those are designed to go in at somewhat of an angle. So it depends on the anchor type. You can also do certain things with if you're using like rebar or something like that as a secondary system, I would say that you can put it in an angle and you're trying to prevent that from pulling out, but you don't want that pulling out of the ground. You want to be almost perpendicular to what that is. So hopefully that answers your question there. If not, let me know. Um, there's feedback on a pole pin. Uh, Joel, if you could give me what you mean by that, I'm not entirely sure. So I'm
Yeah, you've got a base that's in the ground that's cemented in, and the for my instance, and I know you don't like this idea, it screws the pole screws to the base. Well, you put a pin, a big round steel rod in the base that's in the ground that sticks up several inches that reinforces that coupling where everything screws together.
okay. So in the pole, basically.
Yes.
Yeah. So those will stiffen some, but basically you're transferring the load from the outside pole to the inside pole if anything were to break on the outside pole. And then usually you're going with the capacity of that smaller pin on the inside that's less than the bigger pole on the outside. So it doesn't really help you in the long run. It may provide some stiffness before that one fails, but if it were to fail, that inside one's coming down with it as well. So I am not a fan of those inside pins, but if you're using that screw type system, having that in there is better than having nothing in there.
Got it. Thanks.
Sure. Um, Ordinances and limitations for such structures. I guess I didn't talk about that in here. I know I talked about that in another presentation. Anytime you're putting anything like this up, you should check to see if it's legal to do in your area. Depending on where you live, you may not be allowed to put something over the height of your house. You may not be allowed to put something where it could fall into your neighbor's yard. You may have to have it if it is a certain height. You may have to have it professionally designed. There's a lot of different ordinances that may come into play here. If you do something that's relatively small, you're probably not going to have a problem with it, but always check with your town and that to see if there's any problems. If you're doing it on your personal property, you're not going to have as big of a problem as if you do it in a public venue. If you're doing something there, you have a lot more things you have to worry about. You probably have insurance to worry about, regulations on how high it can be, how close people can get, what's going on. But then you're doing that with the entire setup, with your lights, whether they have to be certified, UL listed, all that type of stuff. But definitely check with your town to see what you can and can't do with that. Because the last thing you want is to not only have somebody suing you because it fell onto their property, but then finding out, oh yes, it was illegal as well. Um, there's a question if I can share a picture of my mega tree and its design. I cannot because I don't have a mega tree. My yard really isn't big enough to put a mega tree in there. I have four what I call trees because they're not really small. They're about 5 foot tall. I connect those to PVC connected to a fence post that I drive into the ground. And the four of those I like better than one big mega tree that takes away from any of the lights that I can put um, on my house. So, um, there's another question. Is there a chart anywhere that shows real world forces at play at various anchor uh, points? There is not that I am aware of, but if you watch the Walter Monkhouse video that I pointed out at the beginning, he has some design calculations where he kind of talks about that for different angles, for different wind speeds, and that. It's a very good presentation. He covers a lot of it. He's talked to a lot of other structural engineers that gave him some very good advice. I kind of build on what he's doing there. I'd recommend going through that to see what's there, but there is not a chart that just shows everything that can be done. There's too many variables to really make a good chart on that. Um, Bob points out a good thing that drainage holes in the bottom of a base to let the water out. That's always a good idea. Anything that you can do to keep water from building up, water will corrode all these things. Anything like that you can do is will definitely help you out. And again,
And
don't put
freeze.
anything away wet that causes damage to the lights, the pole, the guy wires, anything like that.
Yeah. Cool.
I do see Chris
Chris
has a
is,
hand up,
yeah,
so go
Chris,
ahead.
is your question related to the presentation?
It absolutely is, actually.
Okay, go ahead.
We can wait until you stop recording. I just wanted to talk to John before he leaves.
Does it have to do with the presentation?
Sort of. I'm getting ready to do a
And
video of my own that I'm going to reference all of this material. But yeah,
okay, either way, ask an hour or wait till we're done. But I think we're covered everything, John. I think we're good.
Yeah, I'll just do one more quick little thing here just to wrap it up before his question. So I just want to say to thanks to Andy for organizing this year.
You're welcome.
Great job with it. A lot of great presentations that you were able to get here. Thanks to all the other presenters that have done presentations throughout the year. A lot of good topics, a lot of good information out there. If you haven't watched those others, poke around them. xLights Gems, it's on YouTube. Got a lot of good information there. And as always, thanks to the Zoom Room crew for being in here all the time, answering all these questions, helping out everybody as often as they can. Um, we spend a lot of time in here helping out people, getting things done, making sure it's there. So we got a great crew here. It's fun to be in here all the time, listening to everybody get the help, and then helping out, and then trying to I think sometimes we try to get through everybody's questions faster than we would in years past, just so we can sit around and talk about other things. So that's part of the fun of it too, is getting what that we're getting better and better at it all the year. So thanks to and everybody for coming to this. I appreciate it. Appreciate the feedback, and hope to do another one of these sometime next year.
Yep.
I'm going to stop my share there. I don't know if you want to
Okay.
stop the recording or
Yep, I
not,
will.
but I'll be around for
And
any
I just want
questions
to
if
say thank you
anybody
again,
has any
John,
others.
for doing this. Really appreciate it. Thank you.
No problem.